Next up is Peter Neubauer. He's going to talk about PLATO. Wait, that's me. First question is, what is PLATO? PLATO is an acronym that stands for Programmed Logic for Automatic Teaching Operations. I'm going to give a little bit of background on what is PLATO, what's the history of PLATO, why is it interesting, and then I'll dive into the Apple II aspect. So I'll start off away from the Apple II, back in the 1950s actually, and then veer back to the Apple II and finish up with a couple of demonstrations. Back in the mid-1950s, computers were a lot different than we're used to today. Every computer was hand-built, usually by a large institution. The whole idea of a personal computer was unheard of. That's not where the technology was. Every computer was a bit different. There was no idea of an off-the-shelf computer. Computing was not interactive in the sense that we have today. The idea of sitting down in front of a computer and typing something and getting back a response was cutting-edge research. Today we take it for granted, but mid-1950s, the state-of-the-art was batch processing. Typically punch cards, sometimes magnetic tape or paper tape. By the end of the 1950s, a research laboratory at the University of Illinois was looking to refocus their research work. Previously, they'd done research work for the defense industry, and now they're looking to reshape themselves away from that. And they're looking for crazy new ideas. What could they do that would be new? And they had the idea of using computers in education. You really need to step back and understand how crazy this idea is. They're talking about taking these arcane machines in research institutions manned by graduate and PhD level electrical engineers and physicists, and then put children in front of it and expect them to learn something. Now, the whole idea of using machines in education was not new, but the idea of using computers in education was crazy at the time, and most of the people at the University of Illinois did not believe it could be done. But nonetheless, a small group at the Control Systems Laboratory began development of such a system in 1960. And then, I believe it was by late 1960, they had their first demonstration. You see a newspaper clipping. Actually, it's dated 1961. Over on the left-hand side is Don Bitzer. He was the project lead, the technical lead at the University of Illinois. So for this demo, they wanted to show off the system that they had just built, the computer-based education system, at a conference that was nearby. But nearby is still too far when you're dealing with a mainframe that takes up an entire room. So what they did is used a telephone line for text going back from what they called a key set, what we'd call a keyboard these days, though their key set was simplified with fewer keys, that would go all the way back over to the university computing facility. And for the video feed, they actually rented time with a local television studio. So video coming out of the computer, went to the local television studio, broadcast it, and this television received it. Bit jury-rigged, but it shows the innovative spirit that this team had, that this team needed to have to push up against the bounds of what the technology could do. And they also showed that it could work. By the mid-1960s, this became a major focus at the Control Systems Laboratory, to the point where they renamed the laboratory the Computer-Based Education Research Lab. From there, PLATO grew tremendously. It saw use around the world at multiple institutions. Development continued. Development and use of the system continued until the mid-2000s. Over its lifespan, over 10,000 hours of original lesson material was developed. It spanned a huge variety of subjects. Certainly the initial PLATO system started off teaching people how to use computers. But from there it expanded to electrical engineering, occult sciences, acid-base titration, English language grammar, neonatal assessment, and Esperanto. And the list is many, many pages long, and you can log into the system and see that later. I just picked these because they just aren't things that you would normally think of as part of computer-based education. Between 1978 and 1985, the PLATO system saw over 10 million hours of use. And it was used well outside that time range, but the records are less complete. So consider 10 million to be the lower bound. The work that was done on PLATO inspired work that we still use today. Many people who use PLATO went on to work in the personal computer industry. Mark, our keynote speaker, mentioned that he worked at the University of Illinois, used PLATO systems, mostly play games. Yes, it was a computer-based education system, but everyone has games on a computer, especially in a classroom. Some examples: Sylvis Warner, Castle Wolfenstein creator, was a PLATO user. Some major titles like Macromedia Authorware, Lotus Note, and Microsoft Flight Simulator also drew inspiration from the work done as part of PLATO. This is an example, this is a diagram showing the architecture of PLATO around 1962. First thing you'll see, there's one computer. This is a very early example of time sharing. There are records suggesting that the folks at University of Illinois invented time sharing before MIT did, although MIT is commonly credited with inventing time sharing. And they were really pushing the bounds of graphics technology at the time. So they had a jury-rig system where the computer would select a slide, like a projector slide. They had various systems for finding the right slide and projecting it. Then a video camera would take the image from that slide, transfer it to a Raytheon storage CRT. That's what the storage device is. Keep in mind, video memory was, I think, multiple dollars per bit. I don't have that in my notes, but video memory was prohibitively expensive. So they needed to use a storage tube to store their graphics. And then the computer would overlay text on top of that image that had been transferred there from the video camera, from the slide that the computer had selected. And then the image from the storage tube would get transferred to a TV display in front of the operator. And then keyset is a keyboard. As I said, the initial PLATO systems used a very simplified keyboard, though later PLATO systems had full-size keyboards with more keys than we have on the Apple II. This is a photograph of a PLATO terminal, I believe a circa don't have the date, I think it's a version of the terminal from the mid-1970s. Later on, the PLATO work drove graphics technology development. Most notably, the gas plasma display, which you see right here. It's the same gas plasma display that's used in television technology today. They were looking for something that could provide fast, flicker-free, fade-free graphics that didn't require them to buy lots of video memory. The plasma display is persistent. PLATO eventually standardized on a 512 by 512 monochrome display, though later versions did add color capabilities. There's a touch screen here as well. Some later versions of the PLATO terminal added sound, as well as client-side programming, a microprocessor in the terminal itself that would allow the mainframe to download code to the local user. Now keep in mind, this is a distributed network system globally. So individual users would sit in front of this terminal, but this is not the computer. The computer is a supercomputer living off in a computer room. There were a lot of other software innovations that PLATO pioneered, innovations that we take for granted today. I already mentioned time sharing. PLATO is one of the earliest examples of multiple people interacting with a single computer. Second is what they called real-time data processing. And this is real-time data processing as opposed to batch processing. That's why I mentioned earlier, the whole idea of sitting down in front of a computer, interacting with the computer, and in real time getting your response. PLATO also innovated an application that they called Notes, which is very similar to email today, online message forums, chat, instant messaging, emoticons. The PLATO terminals had software downloadable fonts, so you'll see a lot of interesting characters show up in the PLATO software. Graphics was very important to many of the PLATO lessons. There is also a set of lesson authoring tools built into PLATO. A simplified programming language tailored to scripting sequences of lessons and what I'll call adaptive training or intelligent tutoring to give the operator, the student, feedback as they're progressing through the lessons. There is gradebook and course management tools, context-sensitive help. That's something that I think took several more decades to see mainstream, but if you're looking at many of these PLATO lessons from the mid-70s and you make a mistake, the system is intelligent enough to recommend what you did wrong. And of course, online multiplayer games. Take a look at one of those later. So PLATO is in operation until 2015. I misspoke earlier when I said mid-2000s. And the system was called NovaNet. It was focused on remedial and special needs education. NovaNet has since shut down. However, there is a hobbyist community called Cyber1. They were able to recover some of the old software, and they have a PLATO server available online. There's also another PLATO server called IRATA.ONLINE. I'll talk about that in a moment. IRATA.ONLINE is focused on retro computing enthusiasts. Most of the historic PLATO users use Cyber1. That's where most of the activity is. So a few years ago, a fellow by the name of Thomas Cherryholmes had the idea of using this PLATO technology to create a retro computer enthusiast community. So taking really old technology, 1970s technology, to build a community for 1980s computer technology. On one hand, it's kind of a crazy idea, but that's also what makes it appealing. All of us like to use retro computers. Why not use even more retro computers? Plus, there's the advantage that PLATO is accessible from retro computing platforms. If you want to take, say, Facebook or Twitter, you better have a fairly modern laptop, fast internet connection, but it's possible to write PLATO terminal programs for most of the 1980s retro computers. And that's what Mr. Cherryholmes did. This is a sample of some of the computers that have clients with terminal programs that are capable of connecting to PLATO. So this list is not complete. You'll want to go to the IRATA.ONLINE website. There you can download disk images for a huge variety of platforms. Everything is open source. You can go over to GitHub, get the source code. There's additional clients that are in development. I think just a few weeks ago, there was a release of an alpha release of an Apple IIgs native version. The 8-bit Apple II version has been out for, I think, about a year in release status. Right now, there's about 700 users registered on the IRATA.ONLINE server. So you can use your Apple II to connect to IRATA.ONLINE or Cyber1 and get more or less the same experience as any other retro computer or your modern Mac or your modern Windows machine. So I think there's a lot of potential to create a community that is much more accessible than some of the other social media communities. Having said that, it is a tough sell to get enough critical mass and content on what's hoping to be a new social media platforms targeted at retro computing enthusiasts. So let's demo this, but first a little bit of background. I'll try to go through this quick. There's a bunch of details on the slides I will not talk about that are relevant to getting connected. These will be posted later. You can refer back to them. So the general idea is you need a PLATO terminal emulator, a piece of software that knows how to talk to the PLATO server, connects over the internet to either one of two PLATO servers, either Cyber1 or the IRATA.ONLINE server. You can obviously do this on your modern machine, but we don't care about that. You can do that on your 8-bit Apple II machine. You will need an Apple II with 48 kilobytes or more. You'll need a super serial card in slot 2. It only works on slot 2. You'll need to set a couple of dip switches that are not documented right now on the IRATA.ONLINE website, but are listed right there. And then you'll need some way to connect your machine to the internet. A modem emulator that connects to the serial port on your 8-bit Apple II, And from the perspective of the Apple II, it looks like a modem, but on the other side actually does a Telnet or TCP connection to a remote server. A popular example is the Wii Modem 232. You can also build your own using a Raspberry Pi and so open source software. However you do it, you have your Apple II connected via serial cable to a modem emulator to the internet. I also recommend a monochrome monitor. All the text is relatively small and done either on double high-res or high-res pages, and it can get pretty difficult to read some of the text. Keep in mind that the Apple Color composite monitors do have a button that can switch over to black and white mode. VidHD also has a mode that allows you to show double high-res in black and white, and high-res in black and white. If you have a newer enhanced Apple IIe, there is another version. Last I checked, the disk image is not posted out there, but the double high-res version works very well. The added number of pixels does slow the screen refresh down a bit, but I think it's worth it for the added detail and resolution. And someone at KFest, where is Michael? He added the double high-res support. Thank you. That's really what the PLATO term project, at least for the Apple II, needs right now. People picking up the software and improving it. The software works well now, but I think there's a few rough edges that someone who loves the Apple II can polish up to make this a bit more turnkey. You can use the 8-bit version on the Apple IIgs, but it does not support the built-in Apple IIgs serial port. You better stick a super serial in there. The 2C and 2C Plus are a bit of a special case. Right now, the code does not support hardware handshaking correctly on the Apple IIc and 2C Plus. Having said that, my experience is that with my Wii Modem 232 set to 1200 baud on a stock Apple IIc, it works reliably. If I go much over 1200 baud, then it can get a little bit glitchy. I haven't checked this, but I assume it's a flow control issue there. The 2C Plus can run a bit faster just because it's an accelerated machine. I typically run 2400 baud on the 2C Plus. I think 9600 baud is pretty reliable as well. You can also run PLATO term in an emulator. Easiest way to do that is with the Micromate emulator. It's built right in. You can also do it with AppleWin. You do need to jump through a few hoops to set up that modem emulation piece in AppleWin. I can help you with that if you want it. There's a few tips right here. It should work with other emulators. I have not tried it. I know that like GS Plus and GS Port emulate serial ports, so in theory it should work, but I'm not 100% sure. And then finally, once you booted the software, you have all the pieces connected, you'll need to issue a command to your modem emulator to connect off to the IRATA.ONLINE website. This is the typical command. Most of the modem emulators support a Hayes AT style command set. I think I have one more slide, then we'll actually show you that. Time permits, I'll also show you the 2GS native version. 2GS native version connects via Marinetti over Ethernet. Any Marinetti supported Ethernet card will work with the 2GS version. The 8-bit Apple II version, when you start it up, it has a nice option that says Ethernet in there, but it doesn't work. You have to use the super serial version. Now, there's some folks working on Ethernet support, but they're just running out of memory on an 8-bit Apple II. Last thing to be aware of is the Keymap. This is a PLATO keyboard. There's a lot of extra keys over here. So you'll want to go to the IRATA.ONLINE website, take a look at the release notes, and there will be a key map showing you the key that is displayed in the software as well as on the keyboard and how to type that on your Apple II. Typically it's a control key. Mapping's not too hard, but it does take a little bit to get used to. All right, now let's really do a demo. Let's start with the 2C. So I've right now I have a stock Apple IIc. I have a Wii Modem 232 connected to the printer port on, sorry, not the printer port, the modem port on my 2C. That's the one that maps into slot 2 on the 2C. And The Wii modem is paired to my phone because I don't trust the Rockhurst network. I've also got a floppy Emu over here. Could just as easily do it off of a 5 1/4 inch floppy. Right now I'm running the double high res version, so let's see if this works. ATDT IRATA.ONLINE. Typed it correctly. Takes a few moments. And we're in. In a moment we'll get a login screen. All right, let's log in as guest. You can also sign up for an account. Turnaround on the account creation is usually pretty quick. There's links on the IRATA.ONLINE website. The Cyber One account creation is a little more involved, but they turn that around in a few days for me as well. The next key that it mentions there maps over to the return key on your Apple II. Main menu. And it's, every time you refresh the screen, it just shows a different retro computer logo. There is an Apple logo in there. Too bad we got a Tandy, but what can we do? Games or lessons? What kind of mood are we in right now? Games. Okay, let's do games. Let's see. This is at 1200 baud, by the way. But it is full double high-res graphics. I'm going to pick Battleship because I know how to play that one. There are certainly more sophisticated games, and someone on the live stream, probably Tom, has just sent us a message down here. Except it says 2018, so we'll just imagine we're in 2018. All right, let's do D for Battleship. And the data key maps to Control D. So it's called Sea Battle, but just like Battleship, except not trademarked. Let's go hit return. Yeah, Michael mentioned that it's downloading the character set that it'll use for what looks like graphics in just a moment. Okay, we know how to play. Sure, so hit return. Let's do a short game. Probably won't even finish that. There are some excellent multiplayer games. They're more involved to learn how to play, but there's excellent help online. There's also original detailed lessons about how PLATO works, keys, concepts. So buried behind all these seemingly simple menus, there's a lot of content. I don't know how many lessons are in there, but probably on the order of several thousand. Okay, we're going to play against the computer. And let's go ahead and pick one. Don't worry, I won't play this whole game. And sure, we'll go with the suggestion. That sounds good. And another ship, sure. Oh, let's do, I don't know, 3-3. All right, probably getting pretty boring if you're not playing, so let's go start at Micromate and Sweet 16. And as time permits, we can dig into some more of the lessons. Micromate, disk catalog, press B. Then under micropacks, comms, and the one with the DHGR suffix is the double high res version. Let's do that. So Micromate's already taken care of setting our display to monochrome mode, and it also has a mod that triggers it to auto connect to the IRATA.ONLINE server, so we don't have to type anything. There we go. That works the same as on the 2C. So let's jump over to Suite 16. This is still an alpha version, but you can download the disk image right now. Obviously color. And it's connecting over Marinetti right now. A little annoying to have two emulators open, so I guess I can't do full screen. There we go. Maybe? I put it over here on the other screen. Sorry about that. Let's get out of full screen. So let's leave it the way it is. I'll log in as guest, and this time, since we had so much fun watching you play Battleship, we're going to try one of the lessons. Color looks pretty good, nice and fast compared to the 8-bit version. Of course, this emulator I think right now is running at 40 megahertz, so. And sure, this looks like a good lesson. And sorry, it's hard for me to read the screen over there. Okay, so the LAB key, which maps to Control L. And this is a serious college level lesson. So it talks us through the Kirchhoff's current and voltage laws, gives us a bit of a tutorial. And then it takes us to some interactive lessons. It gives us a network of current and voltage sources, asks us to solve for, I'll skip the directions, asks us to solve for the unknowns that it's about to list. What is the voltage across node I1? So that's the top left. You can type numeric values or you can type expressions. And if you type expressions, it'll try to troubleshoot what you did wrong. It'll tell you if you got a sign wrong or picked up a wrong value. But I'll let people solve this later. Questions for me? Questions? Yes? I have not done that, but there is a language called Tutor that is built into the PLATO system, and once you get a login to the system, you'll have access to the Tutor system and create your own content. The documentation is out there, it's just extensive and I haven't tried it yet. Yes?
PLATO standardized at 512 by 512. If you have a double high res, you've got enough horizontal resolution to cover that. There are only 192 lines. So what do you do about the vertical resolution?
There is a giant lookup table in the code that is doing scaling. And yes, there's some software in PLATO where the scaling isn't good enough, that you have a one-line feature that doesn't show up when you scale, and it's the best we can do on the Apple II thing, I think. Yes?
Follow-ups and the fonts look pretty reasonable. If you scale the fonts by half or less, they're going to be squished, but the fonts are good. So is something happening different there?
Yes. Custom designed fonts for the Apple II.
There's several character sets. There's like 4 character sets. One of them is the regular alphabet that's embedded in the terminal. So it'd be in ROM, for example, in some systems, but like on the real PLATO terminal. But and then there's a character set for the downloadable character sets that might be for games or whatever. So those are just hard coded to do as bitmaps in the Apple II code. It's an 8 by 6 font. It looks nice when it gets squished. Normally it'd be wide. It looks good when it's squished.
So for the benefit of the recording and the stream, Michael mentioned that there's a set of 8x6 fonts. I think you said 4 fonts? There are 4 character sets in ROM on the original terminals, so the PLATO term software for the Apple II has a custom designed version of those fonts that looks decent at these resolutions. But fonts that are uploaded from the server over to the client, scaling sometimes looks great, sometimes it doesn't look so great because it misses features in the fonts as it scales them. If you want to learn more, I recommend you try it. It's free, it's easy, I can help you set it up this week. Micromate takes no effort to run. Hardware takes a little bit more effort, but it's not too bad once you understand the pieces that are going on. Get on there, try the content, look through those menus. There's really a lot of content behind the initial menu. The initial menu is designed to be easy. Downside is you can think the whole system is simplistic, but it's not. There's lessons on how to use PLATO, there's academic content, there's fairly sophisticated games. Take a look at the IRATA.ONLINE website. There's good information there, download links. If you're interested in the history piece, there's a book out there titled Friendly Orange Glow. That's a reference to the orange plasma, gas plasma displays. And you can also read an article I wrote in the latest issue of Juice.js. Any other questions before I step off? Thank you.